Hi, I'm Andy. We're back again. It's late, but it's not as late as it has been in previous videos. And we are going to make an Android application that draws stuff on the screen, animates stuff like in a game, draws images, bitmaps, stuff like that. So I'm going to call it a drawing sample. You can obviously, if you're following the other videos, you can obviously do all this stuff inside one project. I'm doing them as separate projects just so that these videos can stand on their own. So I'm making a new activity called drawing activity, and if you were doing it all in one project, you would just launch this activity in the way that we saw you launch a new activity in the last video. Okay, so we'll let Android Studio make us a new project. So what we're going to do this time is we're basically going to make a little game loop that updates the state of a little game. It's not actually going to be a game, it's just sort of an animation several times a second and draws on the screen. And we're doing it in a way that will hopefully be will have decent performance. I've been following, in order to work this out when I originally worked it out, I followed this this guide on the Android developer site about using canvases and drawables. It seems to work pretty well. The performance is pretty good, by which I mean it works okay on my phone, and my phone is really old. Okay, so Android Studio has made us a project. It's made us this layout called Activity Drawing. And as you saw on the last videos, for some reason it doesn't like this theme. So if we choose that theme, that error message goes away. So as before, it's made us a layout and it's put a little text view. It's made a relative layout and a little text view. We don't want the text view. What we're going to put there is something called a surface view, and it's going to fill up the whole screen. And instead of doing it on this page, we're going to make it in code. And there's a whole load of hoops you have to jump through before you get a thing called a canvas, which you can actually draw on. We're going to jump through those hoops. Okay, so we're going to delete this text view and go into our Java code, which has been called drawing activity. And as before, in the onCreate method is where we're going to do all the magic. So the first thing we need to do is get hold of this this relative layout that was created for us. We need to give it an ID because it didn't get one. So we're going to call it relative layout. Seems reasonable. Then we're going to get hold of it like this. This is the same incantation that we used before to get hold of something that's got an ID in that XML view. In our code, we do find view by ID r.id.relative layout, because that's the ID. We gave it this ID just now, so this r.id lets us go and find stuff, because it goes and generates some code for us in the background. And then I'm just going to do an Alt-Enter, and I can import that relative layout class. Now we've got hold of this layout, that's what we're going to put our surface view inside. So we're going to say add view, and the view we're going to add is a new surface view. But it's not just going to be a new surface view, it's going to be our own surface view. So just to make it clear that that's what I'm doing, I'm going to call it my surface view. Obviously, when you write your game, you're going to give that class a much better name than that. That's what I'm going to call it for now. I just need to check my notes. I think there's something else I need to do here. No, okay. So we're going to do another Alt-Enter on that, and it offers to create as a class. We'll make that in there. I'll take the defaults. So here's our new class. You're going to watch me fighting formatting again, like I like to do. And this doesn't just extend view, this extends surface view. So we'll make it a surface view, and we're also going to make it implement surface holder dot callback. So a surface view is a thing that is a view that holds onto a surface, or a view that contains a surface. And then there's another thing called a surface holder, which basically handles when you're allowed to draw on the canvas. I think the canvas you can think of as being the thing that's getting held onto. I'm not sure exactly what the difference between surface and canvas is. What we deal with is canvas. Okay, so it says we're not implementing all the methods that we should implement because we're a surface holder.callback. So we're going to Alt-Enter, and we're going to say yes, make me all those methods. Find the formatting. So what's happening here is what we're saying, by saying that we are a surface holder.callback, what we're saying is that we are going to get told when this surface is ready to draw on and when it's not. So we want to draw on our surface, so we need to receive a call on this method, this surface created method, and only then are we safe to draw on the surface. And then if we get this call again, we're no longer safe, so we must stop. Okay, we also need to do something, so I'm going to Alt-Enter again. What was that for? To import surface view, and then we've got to Alt-Enter again to get a constructor. So in order to make a surface view, like a lot of Android things, we have to receive this context and pass it on to our constructor. So the class that made us needs to call a constructor like this. And while we're here, we're also going to, later on, we're going to need a resources passed in. So we'll just pass that through now. Resources is how we get hold of our images and stuff like that. So we may as well put that in now, and I'll show you how we use that later. So where we create this, instead of just creating like that, we have to pass in our drawing activity, which is our context, and we also have to do get resources on that to get hold of the resources for us. Now we're making a surface view, and we're getting told when the surface is being created and when it's being destroyed. So once we've now that we know when we're allowed to draw on our window, that basically means the program started up and got our window all ready for us, and then the user's gone away again, so the surface has gone away, so we need to stop drawing on it. So once we've done that, we need to the next thing we need to okay, so what we need to do is we're ready to receive these events, but we actually need to say to someone, start giving me these events. So what we do is we say get holder dot add callback this. So basically what we're saying here is this surface, you get hold of your surface holder, and then register that we are interested in these events about the surface being created. And basically what we're going to do when the surface is created is start up our game, and when the surface is destroyed, we're going to stop it again. Now obviously, as I said before, don't get excited, it's not really a game, but anyway. So we start off with no game at all. And then when the surface gets created, we fill in this game. And then what we want to do is just tell the game to start playing. So we haven't written this code yet, but we will do soon. And then when the surface gets destroyed, we're going to tell the game stop. And just for shiggles, we're going to set it to null again. So I actually think what we should do here is check for null as well. So in some circumstances, maybe we get this surface destroyed event and we haven't, things are not as we expect. So game hasn't actually been set up yet. Well, let's not try and stop it. I don't like randomly inserting null checks, but I think that genuinely might happen at some point. So let's be safe in this case and just say if there's no game, we won't bother stopping it. So what happens is when the surface gets created, we create this thing called game, we tell it to start, and then when the surface is destroyed, we tell it to stop. And we're also supposed to handle this surface changed thing. So I strongly suggest when you write your game, you handle that. I haven't been handling it when I've been playing around with this, and nothing bad seems to have happened, but I think that's because there are situations I'm not trying out, or even it could be even different devices where this works differently. So I think you need to think about that, and I think what that basically... Yeah, I don't know. You have to think about that. I haven't. Okay, so we've made up this this thing called game. We don't know what it is yet, but let's make one. So we're going to alt enter on there and create another class called game. And actually, what this class is going to be for is basically for starting a thread that has the actual game loop inside it. That's what we're really using it for. So if we'll enter on here, it will make us a method called start, and let's do the same thing for stop. And basically what we're going to do is create a thread in the start, and start that thread, and then ask the thread to stop again when we stop. So basically we are going to have a thread which we're going to use to launch our game loop. And a game loop. And when we get told to start, we create a thread. Well, what we do is we create a game loop. And the game loop is going to be runnable, which means we can pass it into the thread. And then we start the thread. And then when we get asked to stop, what we're going to do is tell the game loop to stop looping. Now, I've called that method please stop. I'll explain that in a minute, because you might think that's a slightly odd name. So basically, when we get told to start, we create this loop, and it is an instance of runnable, so it gets past the thread. We tell the thread to start, and what that means is another thread of execution goes off. So basically what's happening is our main game loop is happening outside of the normal loop that Android uses for drawing the screen and stuff like that. It happens separately, and it gets complete control over its own timing. So what it does, when it needs to draw on a screen, it says to Android, give me a canvas, and then draws on it, and then gives it back when it's done. And it can do that as frequently as it likes, assuming it's running quickly enough. We don't have to wait for Android to sort of do the UI refresh stuff that it does. We're in control. So this is really for games that we would do this, not for a normal UI where you actually want Android to be controlling the timing of things like that. But in a game, you want your own fine control. Okay, so what we've got a load of errors, so let's get rid of them. Alright, well, let's start off on making game loop. And game loop is something we can pass to a thread, so it has to implement runnable. And that means it needs to have a run method. I'll do that in a minute. It also has a please stop method. Now it may become clear to you why I've called this please stop and not just stop. Runnable actually, threads rather, have a method on them called stop, and that is deprecated and you shouldn't do it. So just to make it absolutely clear, this is a polite stop rather than the horrible stop that you get on thread, which you shouldn't use. I'll call it please stop. Okay, we'll get to that in a sec. So what's happening here is we start the thread in start, and then in stop what we do is we tell the game loop to stop looping, and we are confident that soon it will stop looping. And what happens when a runnable comes out of its run method, then the thread stops running. So what we want to do, just to make this feel neat and tidy and know that everything's working, we could probably get away with not doing this, is we're using thread.join to say wait for that thread to terminate before you leave again. It just seemed right to me to do this. I'm sure it doesn't make any difference, but it just feels like the right thing to do. So join just means wait for that thread. perhaps wait would be a better name for that. I mean, it sort of means join that thread into this thread, but it doesn't really actually join it. What it does is wait until it finishes. Okay, so you're going to see this a few times as well. When you're waiting, like in join where you're waiting for another thread, it's possible you will get sent a signal, you'll get sent notify from another thread, and if that happens, you will get an interrupted exception. However, we're not going to use notify in this program at all, so there should never be any interrupted exceptions. But because Java uses checked exceptions, we have to put this rubbish all over our code. So that should never happen. And that's our game ready. This just manages our thread for us. And then the real fun stuff happens inside game loop. So let's have a quick look at game loop. Fairly soon we're going to be ready to run our program. It won't actually do anything, but we'll see this loop looping, and we'll know that what we've done so far kind of makes sense and works. So the normal structure of a thread like this is you'll say something like while running do something, and what we're going to do is we're going to write a log message, and then we're going to wait so that we don't completely kill the phone. I'm going to wait a second for now, since this doesn't have to be very performant at this point. So we're going to need a member variable called running. At the beginning we're going to start off running, and here's where the please stop comes in. When you politely ask us to stop, we'll set running to false, which means we're going to eventually exit out of this loop, but not immediately, you'll notice, only when we get to the end. And that's why it's a please, because we're being polite. Okay, and so thread.sleep, same as what I was saying a minute ago. If your thread is waiting for something, it might get interrupted in theory, but in this case nothing is going to interrupt us, so we're going to ignore this exception. Basically we're going to print it out to the console. By the way, normally if you're ignoring an exception, I would suggest, if you're absolutely sure it should never happen, I would suggest wrapping it up in a runtime exception, which means you don't have to declare that your method throws this or anything like that. But I would rather, in general, normally, what I would like to do is, if something happened that I know should never happen, I want to know about it. So I'd like to throw a runnable exception, a runtime exception, sorry, and that will might crash my program, or it might finish this web request with an unknown error or something like that. What that means is that when something that should never happen happens, which often does happen obviously, you find out about it and you fix it. Whereas if you just dump stack trace like this, you might or might not notice it depending whether you're looking at the console output. So I would strongly recommend not doing what I'm doing here, especially in sort of production code. The reason I'm doing it here is because if there's something I don't understand that means we do get an interrupted exception, perhaps there's some way of the system notifying a thread or something I don't know about. In this case, I still don't think anything's gone wrong. If we get that interrupted exception, someone's just told our thread to wake up when it was sleeping, well, fine. That's not a problem. It's not an error. There's nothing in particular we should do about that. It doesn't mean, for example, we should break out of this loop or anything like that. It just means someone told us to wake up when we were sleeping. So I think throwing a runtime exception here just because I happen not to expect it to happen is a bit of overkill. But in general, if something it's something that should never happen happens, throw a runtime, wrap it in a runtime exception and throw it. And while you're at it, enable assertions whenever you run any Java code. Okay, so complete sidetrack rant over. So now we've got a game loop which basically just says keep going forever, print out running, wait for a second, and then go around again. And then when we get told to stop doing that. Okay. I'm trying to think whether we're now ready to demonstrate this. I guess the best thing to do is try it out and see whether it goes wrong. So I've got my phone plugged into my computer as before. I tell it to run our program. it will either tell me there's some awful compile error, or it might work. Let's find out. And if it's working nicely, what's going to happen is we're going to get a log message written out to the log once every second. Over here, I might be more out of the way. You get a log message written to the log once every second saying running, and what that means is that all this stuff about getting hold of the surface holder and all that has actually worked. Okay, so here's my phone all plugged in and things. I'm just going to say use it every time and say OK. So it's built the code, it's copying it onto the phone, and then it's going to run it. And if we're very lucky, we'll get some log messages. There we are. Running once a second. Brilliant. Okay, so now it works. So, there we go. I'll leave that running. Okay, so that's the kind of framework for the game loop. And then the main thing we've got left to do is actually implement a proper game loop here instead of this demo thing here. So instead of logging a message, what we're going to do, let me check my notes, is we are going to process input, do physics, draw graphics, wait for the next frame. Right. I've lost it again. Do physics. I'll talk about what I mean by all these things. Draw graphics. Wait for next frame. Okay, so basically, in a normal game, what you would have some input, like from the keyboard or something that you were interested in finding out what the user was saying. In this game, we're not actually going to have any input, but I put that in there just to show what you would put. And then in any game, you're going to have do physics or some kind of physics, which I basically mean work out what's happened in the game world. Then draw graphics, which means draw the game world onto the screen. And then, if necessary, if we've gone fast enough, wait until it's time for us to draw the next frame. So that's the kind of outline of our game loop. So let's just make those methods. Leave them empty just to stop it being all red all over us. And then we'll talk about how to implement each of them. So as I say, process input, I'm just going to leave empty. It's not going to have anything in it at all. The others are going to have stuff in. Some of that stuff is going to be more like what you'd have in a real game. Some of it's going to be a bit of a made-up thing. So where should we start? Let's start with do physics. So yeah, let's talk about what the game is going to be. So what the game is going to be is we're going to have a load of balls bouncing around the screen. Just to show, those balls are going to be images, all the same image actually, so we won't confront any of the issues we have on Android of loading lots of images and running out of memory. But we're going to draw balls and they're going to move around. So let's do that first. So we're going to have a load of balls in our game. So we're going to have a class called ball, which is going to represent one of our balls, and we're going to, in order to have lots of them, we're going to have an array of them. So let's make our array. We're going to have a constant somewhere that tells us how many balls we've got. So let's do that. Let's start off with one ball. Later on we'll have lots. So what was I going to say about that? Yes, this class, this game loop class, I'm going to dump an awful lot of code in here. And in your real game, you wouldn't do that. you would have separate classes for doing these different bits: process input, do physics, draw graphics, wait for next frame. I'm as far as possible, I'm keeping them all together so that we don't have to go to too many different places to see what we're doing. But in the real code, I really think you should split that up. So don't follow what I'm doing here to that extent. But this is basically just to get you the idea of the structure of the thing. Okay, so we need a class called ball, and balls are basically going to have a position and a velocity. So let's we're going to have an x and a y, and a vx and a vy, which are their velocity. Let's make this. And people on the outside are definitely going to have to see their position. And while we're here, let's just do the constructor, shall we? While we're here, so basically we're going to have a random number generator passed into us because the ball's going to be created in a random position. And again, I don't think this is necessarily a very good style for this ball to use a random number generator to position itself. I would generally prefer to pass into the state of this ball into it. But the code, I had so much code in game loop that I ended up putting this stuff in here. Okay, so please forgive me. So I've decided that the balls are going to live in a 100 by 100 game world. So what that means is we're going to put them between 10 and 90. Which looks like that. So y is going to be the same. And they're going to have speed of between -0.5 and 0.5. Next float gives you a number between 0 and 1. So if you add -0.5 onto it, you get -0.5 to 0.5. So that's the that's a ball starting from 10, ending up somewhere between 10 and 90 for its x and y position, somewhere between -0.5 and 0.5 for its velocity. So these balls are going to be moving around the screen. Okay, so let's leave it like that for now. So we've made we've made an array of ball, but we haven't actually put anything in there yet. So let's create some balls to go in there. Remember, of course, for now there's only one, but very soon there'll be more. So let's do it properly. So create new ball. You see what I mean? I could have done all this randomness stuff in here, but there's just enough code here already. So, but we do need a random number generator. Don't pass in the time. That's less secure apparently than just using the default constructor. But of course we don't need secure random numbers anyway, so who cares? Okay, so now we're passing random number generator into ball. Ball's making itself be positioned in a random place. I don't know why. I always make things public. I don't like implicit protected. Don't ask me why. Okay, so the point is we've got these balls. So the physics step is going to make the balls move. So that's really quite straightforward. All it is go through the balls. And tell each ball to do a time step. But of course we don't have a time step yet, so let's implement our time step. And it's exactly how you'd imagine. We move it by Vx in the x direction and Vy in the y direction, and if it goes off the edge, we bounce it. So if x is less than 10 or x is greater than 90, Vx equals -Vx, right? Same for y. So now that's the physics, such as it is, for some balls bouncing around the screen. And all our do physics does is do that. So that was straightforward, wasn't it? Okay, so we know process input does nothing, do physics does that. And then wait for next frame is quite interesting. So in fact, and there's a little bit more around do physics as well. So let's have a quick look at my notes. So yeah, so we need to keep track in order to skip the right number of frames and do the right stuff like that. We need to keep track of what time it is in our game world versus what time it is in the real world, so that, for example, if it took us a long time to do some calculations, or rather if it took us a long time to do some drawing, well then we're going to have to catch up by doing several steps of the physics in order to catch up with the time it is in real life. Otherwise there's going to be juddering in our animation. So the way we do that is we keep track of the time, what time it is in the game world. The way we do that is we keep this variable called simulation time, which tells us what time the game world thinks it is, and it starts off being the actual time. And every time we do the physics, that potentially is going to change, or definitely going to change, because you're going to do some physics, and then at the end of that, it will be some time will have happened in our physical world. So we're going to make this function return the new time. So we're going to pass in the current time in order to be able to do that. And we're going to return the amount of physics steps that we did is going to affect what we return here. So let's have a quick look at my notes, because there's actually a bit more to do in this physics world. So at the moment, what I've done is just do a time step for all the balls. But actually, we need to be cleverer than that. So let's move out this code, the moving the balls code. Let's move that out into something called move balls. Desperately remembering the code that I wrote just moments before I started recording this video. So this is the move balls code, which obviously is going to get called from do physics, but it might get called more than once because we might be doing more than one physics time step. In fact, what we're going to do is this ish. Yeah, right, I'll type it out, otherwise it's going to get crazy. Okay, so it's a for loop. We keep track of how many times we've done this by saying skips, which is a number of times we've had to do physics in order to catch up with the time it is in the real world. So we're going to say basically we're going to exit this for loop for one of two reasons. One is that we've skipped too many times. I'm going to make a constant called max allowed skips. Or if we've actually simulated enough physics that we've caught up with the time in the real world. So that's this part. So if our time in our simulation is caught up with the time of the next frame, or the time of this frame, then we know we've caught up. So if our simulation time is caught up with the time of the frame starting, then we can stop looping because we've done enough simulating. So actually, let's put in the actual simulating. So we're going to move the balls every time around this loop, and presumably the first time we come into this loop, this won't be true because some time will have passed and we'll need to run some simulation. What it does mean is we need to pass in when that frame started. So when we call do physics, we're going to pass in the frame start time. So the frame start time is literally just the time when we started this frame. So let's keep track of that. Yeah, it gets set up by wait for next frame. For now, let's set it up here and then I'll show you how we do that in a minute. So by the way, this little idiom here, in order to get the number of milliseconds since 1970 in Java, you have to make a new date and then call getTime. Don't ask me why, but that's the way it works. So we start off with the frame start time being the same as the simulation time. And in fact, yeah, let's move the update of that to the end of the loop because it just kind of makes more sense then. So we've made it here. So basically, this time starts off being the same as simulation time, and then as we go around the loop, this time gets updated to now, and then physics basically moves the physical world until it catches up with now. Oh, I got that wrong. So yeah, this is the time. This time now, and then physics has to catch up so that it's where all the simulation agrees with the real time. However, that's all very well. We will simulate as quite a few times until we've caught up with real time, but we won't allow that to go on forever. We'll actually basically introduce some judder into the game, and the reason for that is if we allowed the physics to go on for 5 minutes because the phone got really overloaded, and then we updated a new frame, well, that's unfair on the person playing our game because they haven't been able to see anything happening for the last 5 minutes, but it's still been happening. So we have this maximum number of frames that we're going to allow it to skip, and if we take longer over things than that, we're just going to have to put up with the fact that the game's going to slow down. This basically seems to be the best compromise in terms of getting decent performance. And I'm going to allow you to skip up to 10 skips. So that's not actually 10 frames of animation, that's 10 lots of physics. And so if the physics is significantly faster than the actual animation frames, then that wouldn't actually cause much juddering or any juddering at all. But yeah, we'll see about that. We'll get to that in a minute. Okay, so doing the physics involves keeping going either until we've skipped too many frames and we're just going to have to allow some juddering, or the simulation has caught up with the time we need to get to. But in order for it to catch up, we need to increase it. So the increase is, I had a good name for this variable, so I want to look it up. Yeah, simulation time step milliseconds here. So every time we move the balls, what we're saying is that amount of movement represents this many milliseconds in our game world. And we're going to have that as just another constant. Whoops, and I think the number I had for this is 5, and that seemed to work okay. So every time we move that ball by that velocity of between -1.5 and 1/2, we say that took, in the physical world, that took 5 milliseconds of time. Okay, what's my error? Oh yeah, we're not returning the answer. So at the end of all this, we've updated the simulation time. How many times around the loop we've gone. So we're just going to return that back from do physics, and then that gets stored in this local variable in our game loop. We could do this with some kind of member variable, but one should avoid member variables whenever one can. Okay, so that's the physics. In a minute we're going to draw the graphics, but first of all let's do a waiting around for the next frame. So if the physics all went nice and quickly, if the drawing of graphics all went nice and quickly, then actually it's not time for us to do another set of physics yet. So we're going to wait around for a bit. And the amount of time we're going to wait around is basically the amount of time until the next frame. needs to be drawn, it needs to get processed. So what we do is we're gonna, well, let's set that up now. So we're gonna have wait for next frame actually return that that next time, the next time step of when the next frame is going to be. We'll pass it in because we're going to need to pass it in order to be able to pass back a modified version of it. So if I seem uncertain on this stuff, it's because I'm not a games kind of a guy. So this is all new to me, so it's probably all wrong. But I have tried to follow the Android tutorials on it as much as possible, in terms of getting the animation right. Probably I'm being hopelessly naive about how games work, and probably I've made some basic mistakes in how I've done the Android stuff as well. So make sure you leave comments telling me what I've done wrong. Anyway, in order to wait for the next frame to happen, we have to find out when the next frame start time is. And then we're going to return that, and that's going to be the frame start time next time around the loop. So the next frame start time is basically now, and we have to find out how long we have to wait for. Is basically how long a frame is minus how long we've taken so far. So how long we've taken so far is time now minus the time it was then at the beginning of the previous time around this loop. And then therefore how long we have to wait, let's call that wait time, is how long a frame should be minus how long we took. So this how long a frame should be, well, I reckon if we draw to the screen 50 times a second, that's a reasonable refresh rate for most things. So 50 times 20 is 1,000. Yeah, that is right. Okay, so this is basically 50 frames a second. Drawing on the screen. So basically, if we've gone so quickly that it's not yet time to draw another frame, if we draw in frames at 50 frames a second, well, then we sleep. So we sleep for the length of time that we need to wait in order for how long we took to catch up with how long a frame should take. And yet again, I'm afraid we've got an interrupted exception, which should never happen. Same thing applies. Always don't do what I've just done. All right, don't just print the stack trace. You're much better off throwing a runtime exception. Then you'll find out about it when it happens. However, in this case, if it happens, it doesn't matter. It's all fine. All right, I'm going to stop going on about that. Okay, so that is how we wait for the next frame. We basically find out what the time of the next frame is, find out how long we took, wait for the amount of time we should have taken minus the amount of time we actually took. The only other thing is, just for completeness, to avoid doing work we don't need to do, fiddle with my formatting. I really ought to set up Android Studio with the way I like formatting to be, and then all this stuff would be a help instead of a hindrance. Okay. Anyway, if we're going to wait at all, then sleep. Otherwise, don't. Okay, so straightforward. All right. So now we've got everything going, except we're not actually drawing anything on the screen. So let's draw some stuff on the screen. Oh, I've got red. Where's my red? Log statement. Okay, I don't know why I'm red. Okay, so drawing graphics is just a matter of some of the complicated hoop jumping we have to do to get hold of our canvas. So we we are working inside a surface view, and the surface view gets notified when the surface got created. So what we're going to do is we're going to pass in to this game thing the surface holder that we've been given, which is basically our way of getting hold of the canvas. And while we're here, we'll also pass in this resources thing that we got given. I'll make a field called resources. Thank you for making it final, I appreciate it. Okay, and we're going to pass through those resources into the game, and the game is just going to pass them straight on through to the game loop. And in fact, that's making me wonder whether I should make the game loop in the constructor here, and then we wouldn't have to have any member variables for that stuff. I think it does. This is basically a use once object. It just gets created and then started. So, in fact, if I do this, I can have those variables final, and everyone loves a final variable. Final variable that you can see being initialized cannot be null, and therefore you don't have to check it for null. How great is that? Okay, so let's get back to what we were actually doing. So pass through the surface holder and this resources thing, which is this mystery that we are going to need it. So I'm going to make it. So the game loop constructor, I just changed it to take in these new things, and what we're going to do is hold on to them. So when things get complicated in terms of what's a member variable and what's not, I like to, in the constructor, I like to say this explicitly, and I also like to name things, name the member variables the same as the constructor arguments. So this trick works for that. But if I'm doing that, if I'm doing it for any member variable, I like to do it for all of them. So I'm also going to change balls to be referred to in that way, just in the constructor, just when we're assigning it in the constructor. So we also do we have a resource. Actually, we don't need to hold on to the resources. I think we're going to use the resources in the constructor. No, sorry about the mysteryness of that. We'll get to this very soon. It's how we get hold of bitmaps, actually. Okay, so now we've got a surface holder in our game loop. That surface holder is going to be how we get hold of the canvas that we actually draw on. Let me just check what we do. How many classes did I break this into? Okay, I didn't break it into any. Good. Okay, I did it all in here. So as I said, I'm sorry, there's a lot of code in here, but it just keeps it together, doesn't it? So take it as read that in real life you'd have separate classes. Okay, so the way we get hold of the place we're actually going to draw stuff is we say surface holder, which we've passed all the way through now, dot lock canvas. So what that means is no one else can do any drawing on that canvas. It's ours. And it might be null. So if it's null, that means you're not allowed to draw on it yet. It's not ready for you, or something like that. Or maybe we failed to lock it. I don't know. Anyway, it can be null, and if so, we just don't do anything. Now we have to be very careful that we always unlock our canvas no matter what goes wrong. So we're going to have a try finally block, and assuming canvas wasn't null, we are going to unlock it no matter what happens. So what this means is take off this lock we've got on our canvas, and also draw this canvas that we've been drawing to actually do the drawing. So that's what that means. So now in here we've got a canvas that we know isn't null, and we can draw to, and safe in the knowledge it will get unlocked and sent to the screen no matter what happens in between. So what did I do in here? Yeah, and there's more you have to do. So to make sure that no one else is interfering with us while we're doing this, we need to be synchronized on surface holder while we do it. I actually rather wonder whether we should synchronize around this whole block rather than just in here. Because what if someone else... I think I copied this from somewhere authoritative, but you may want to look it up as well. Basically, we don't want anyone else calling any of the synchronized methods on Surface Holder while we're doing stuff with this canvas, or something like that. So you can see that it is a bit hoop jumpy, isn't it? So once we've got hold of a canvas and we know that everything's locked the way it should, we can separate out our actual, our real useful code into another method. And where I did this in a proper game, I actually made just this little bit a separate class. I like that to be almost separate. I think that was good. Here everything's mixed in, but hopefully, well, different methods. You can still see they're separate. Okay, so when we're actually drawing the graphics, we're going to do something pretty simple. We are just going to blank out the screen. So the canvas provides a method called draw color, which blanks out the screen, and we're going to draw each ball. So loop through all the balls, and for each ball, draw it on the screen. And what we're going to do for that is canvas.draw bitmap, and we're going to have a bitmap which is the ball. So this would be a lot more complicated if you've got loads of different bitmaps or you're animating something or something like that in your game. For us it's nice and simple. We're going to have one bitmap we're going to use for all our balls, and we're going to draw it on a screen. Now, as I said, those balls are in a game world, which is 100 by 100. So in order to draw them on the screen, we need to scale that to fill up our canvas. So that 100 by 100, I'm just going to stretch out to be the shape of our screen. So I know that my bitmap image is going to be 32 pixels wide. So the first thing I need to do is move it 16 pixels to the left, and then I'm going to scale up that 100 by 100 to the size of the canvas by saying ball.x divided by 100 to get it between 0 and 1, multiply it by the width of the canvas, and then the y coordinate is going to work exactly the same way, but it's the height of the canvas. We also have to provide a paint object. Whenever you're drawing anything on this canvas, you have to provide a paint object. Our paint object's never going to change or do anything clever. We're drawing a bitmap and we don't want it transparent or anti-alias or any of the things that these paint objects provide. Is that all I've done? Yeah. So let's make these. So a member variable called paint, which I think could be fine as well. Yay! Paint is just going to be a paint. Ain't going to do anything clever. And the bitmap is where we're finally going to see why we passed in all these resources. That is an Android bitmap. So how we make the bitmap is with the following incantation. I've forgotten. Resources dot bitmap. What is it now? I've got to look it up. I thought I was going to show off that. Bitmap factory dot decode resource. This basically means load up a bitmap. Okay. And the resource that we're going to load is using this resources thing, hence why we passed in resources, yay! And we're going to ask for a bitmap that we have put in. So let's put it in. So here's a bitmap I made earlier called ball.png. So I'm going to drag it in and drop it in my drawable MDPI directory. So basically all of the images and stuff like that that you want to use get stuck in these resources directory. Drawable MDPI is for medium DPI, so basically phones with a sort of moderate resolution will use it, but I think phones with a high resolution will fall back to whatever they can find. So if you don't put stuff in these other directories, it will load them from there, but obviously it'll look rubbish on a modern phone. So actually, even though M stands for medium, actually it's the lowest resolution phones these days. So there's a high, extra high, and extra high. And if you're doing a proper game, you need to provide images, nice high resolution images in there that will get used by your game. So now I've dropped it in there. There it is. I ought to be able to do what is it? Drawable, I think. Yes, drawable dot ball. There it is. And look how beautiful it is. It's even put a little graphic of our bitmap in this column here in our editor so we can see it. So basically what that says is load a bitmap using this resources thing, which is just how it finds stuff. And the bitmap that I want to load is the one that's called ball in our drawable section. Okay, so now I've got a hold of a bitmap and I'm asking it to draw that bitmap here. The position I want it to be drawn at is the position of this ball using this paint. So have I finished? Let's try running it, see whether it works. And if it does work, it's going to be the beginning of an awkward section of the video where I'm holding up this game in front of the camera several times for you to look at, because unfortunately, because this is an animation, taking screenshots, static screenshots of it isn't going to be particularly effective. Hey, I can see a ball bouncing around the screen. I am going to do you a screenshot just because it's so much less annoying than holding the phone up to the camera, but then I'll hold the phone up to the camera and you'll be able to see a ball bouncing around the screen. I'll wake it up so it's nice and bright, in fact. So here's your screenshot. Let's turn it round. It's a little annoying. Yep. So you can see, oh look, there's tearing happening on these screenshots. I assure you there isn't any tearing happening on the real screen. I will show you. See whether I can make this visible and not unplug it or things will go really bad. So can you see, it's terribly out of focus, but can you see that it, not only is it moving, but it's animating nice and smoothly. That really is appalling, isn't it? Okay. You're just going to have to believe me, it looks really nice and smooth. So that was with one ball. Let's show you how it goes. If I have 10 balls, I wonder whether there are any bugs in this program that means it works for one but it doesn't work for 10. Let's have a look. So I've hit run again. So it's just loading the new version onto the phone. So when I was doing this earlier, I was pushing it to the number of balls I could manage to get to work nicely, and I was pretty pleased. So here are 10 balls. Again, you can see that looks pretty smooth, doesn't it? So you'd expect it to look smooth with 10 balls. Let's try 100 balls. I'll wait for it to kill it and start it up again. And when I pushed the system quite a long way, it looked okay, but it seemed to have trouble loading up the new game while the old game was still running. So I had to use terminate in the Eclipse thing. I'll show you in a second. Okay, so there's 100 balls. So that's drawing. That's clearing the whole screen, and then drawing 100 bitmaps, and it's it's pretty much keeping up with the frame rate there. The frame rate looks nice and smooth, no juddering happening. So just because I know you want me to, let's push it a bit further. Yeah, so when I was pushing it really far, I was getting it to log out when it did skip frames, just so that I wasn't just going by eye about whether it looked smooth. And when I pushed it up to 500 balls, which on a screen this size is basically as many bitmaps as you're ever going to need, surely. It wasn't skipping too badly, even with 500 balls on the screen. Now, when I look at it, it looks to me that there's a bit of judder there. You can see that's not as smooth, is it? But it's reasonable. I would say, let's take a screenshot of that. I would say that's pretty much as many bitmaps as you are going to want on your screen. Again, there isn't actually any tearing on the screen. This is a tearing on the screenshot. Obviously, the screenshot is happening too slowly. If you can draw 500 bitmaps with a bit of judder, but it still looks like they're moving around quite nicely, and you're clearing the whole screen beforehand, so that means you can basically get away. What I'm saying is you can get away with, on an old phone, this is an old HTC Wildfire S, you can get away with redrawing the whole screen from scratch every time. You don't have to worry about only redrawing the bits that have changed. And you can draw pretty much as many bitmaps as you need on the screen using this technique. Surely you don't need more than 500 bitmaps. Certainly for the game that I'm writing, I probably need to draw certainly under 100 bitmaps per frame on the screen. So it seems like the days of worrying about exactly which bits of the screen we're painting and things like that are over, because even on an old phone you can just draw the whole lot. Not even think too much about it. I'm sure some games programmers are tearing their hair out hearing me say such a thing, but anyway, it looks like by following the advice that they give you on the Android site about how to do animation, you get pretty good smooth animation without being too clever. The thing you do still have to deal with, I think, is loading a lot of bitmaps into memory. Even if you're not drawing that many in one frame, if you've got a lot around that you need to draw at various times because you're animating and stuff like that, you can definitely run out of memory, and that can be a problem that a lot of people come up against. A lot of the kind of unexplained crashes and people getting 0 stars on their Android app page, I think, is from running out of memory from loading too many bitmaps. So there we are. I think that's probably the last sort of general how to do this Android thing video I'm going to make. The next one I'm going to make is going to be about this specific game that I'm writing called Rabbit Escape. I'm going to talk a bit about how I managed to separate, or how I wrote the code without doing any Android stuff at all, just in pure Java, so that I can unit test it all and test it all on my machine without running it on my phone. And I haven't actually done it yet, but when I've got it working on the phone, I'll talk about how that kind of pure, not tied to Android world can then be integrated into a nicely running Android program, assuming it can. And take you through a few things about how Rabbit Escape is implemented in terms of the actual game world, things like that. And gradually I think you'll come through with me to hopefully a point where I'm releasing the game on the Android store and you'll go out and buy it and tell your friends. So hopefully there's a subscribe button somewhere on the screen about now. Do subscribe for more videos. Check out my blog, artificialworlds.net/blog. Check out artificialworlds.net for all different open source projects, stuff like that. On Twitter I am at Andy Balaam. My YouTube channel is at AJ Balaam. And see you next time.